Hey, what is up everybody? Welcome back to your 6th Oracle SQL tutorial. This video we're going to be talking about relationships. Alright, so this is a straight up dating advice tutorial. Alright, this will get you all of the ladies. By all ladies, I mean probably 0 or less. And yeah, it might get you a programming job though someday. So, alright, so let's begin. We're going to start talking about relationships. And if you don't know anything about database relationships, this is the tutorial for you. Well, everything in a relational database has relationships. And when we say relational database management system, you guys remember that? I think I talked about that. Relational database management system. Well, this R does not mean relationships. It means relational, which deals with the concept of relations, which has to do with tables. So basically a relation is just a table. So when I say relationship, just want to make sure you guys are clear that don't be going around saying relationship database management system or something like that, because then you won't get the job or the ladies. Yeah. So before we go about designing these relationships, let's just talk about some conceptual information that you should know before you start diving into the whole diagramming stuff. Alright, so the first thing are the 2 words you need to know. Entities and attributes. These are basically 2 kinds of information in your database. An entity is anything we store data about. An attribute are the things about that entity. That means an entity has attributes. Okay, so in this example, you can see this entity right here has an attribute, an attribute, an attribute, and an attribute. So basically the attributes describe the entity. So how do you know if something is an attribute or an entity? Well, if you can think of a bunch of information about this, okay, just think if you have an object, right? Just something you want to store data about, or something you want to store in a database. And you're asking yourself, okay, is there a bunch of stuff I can store about this object or this thing? If there is a bunch of stuff you can store, then there's a high possibility that it is an entity. If you can't think of anything that you need to store about it, then the likelihood is that it's an attribute. Now, sometimes you can make it work either way, and I'll be explaining that. So don't get so caught up like, oh my goodness, I don't know if this is an entity or an attribute. Usually, once we get into database normalization, that'll kind of work its way out. But when you start off with just some basic entity, attributes, and relationships designing stuff, then when you get into normalization, it's like a piece of cake because you basically already have it done. All right, so let's kind of just go through some examples, all right? If you have a database for a college, and this college has a class. This class would be a specific class, so we could say it's Math 4070. Now this would probably be our entity. That's because there's going to be related information that's going to describe this class. So we could have, a professor, student, have room number. So that's going to say where the class is located in the school. And if it's a big school, you might have building and room number. But we'll just go with room number for now, for simplicity's sake. And you also might have a time. So we could just say Tuesdays at 4:30 to 5:30. It's a pretty short class, only once a week, and it's only an hour. There's a whole bunch of information here. I just want to try to go through this and try to figure out what would qualify as an attribute and what would qualify as an entity. So you look at this and you kind of just ask yourself, all right, can we store information about each one of these? For example, a room number. Can we store anything extra about a room number? Not really, it's kind of just a room number. It might be 432, right? What about a student though? Well, a student, that's like kind of important. It's like a human being. And human beings are pretty important, So the chances are you can store information about a student. So, you could have what's their name, what's their student ID, what's their major, what class are they in, stuff like that. So this would probably be an entity. Professors, same thing. Those professors, they're people sometimes. Now, what about this time of the class? Well, can you say anything about the time of the class? Not really. That would probably be an attribute. So when we break this off into entities and attributes, let me clean off the board a little bit, we get something that looks a little bit like this. We have a table and we can place the entities over here and the attributes over here. So for the entities, we have the class, the student, and the professor. We also had some attributes that were specific to the class. We'll just put these over here now. So you can kind of see how this is working. We're separating the entities from the attributes. And yes, these attributes are very specific to just the class. But that being said, we could add more attributes that describe the other entities. A name. Well, that could describe a student or a professor. Birth date, same thing. That could describe a student or a professor. What about a major? Well, professors could teach in a specific major. For example, we could have a nursing professor, but generally when you're talking about a major, you're talking about students. And I don't know why I decided to do those ones in black. Let me clean that up a little bit. Oh, I think I just made it worse. But you guys follow. Well then, what does this mean when it comes to database design? Why did we do this? Why did we waste our time making this graph? Well, we actually didn't waste our time. The way this works is you will take the entities and you will make them have their own table. So each entity is going to get a table. Attributes, on the other hand, are only going to be a column within that table. Without worrying about all the details, you can get a basic database design by following this concept. That means we have 3 tables. We have the class, the student, and professor. As for the attributes, such as the time of the class and the room number, those are just going to be a column within this class table. So within this class table, we're going to have those 2 columns, room and time. As for those other attributes we were talking about, such as name, well, those are going to go in both of these tables. You can get a very basic database design starting point using this method. Now, we talk a little bit more in depth about the concept of relationships, because these tables relate to one another. For example, a class is taught by a professor. Students attend the class. You could also maybe say that the professors teach the students, or the students learn from the professors. So we're going to talk about the 3 types of relationships right now. The first kind of relationship we're going to talk about is a one-to-one relationship. And if you're a visual learner and need some kind of picture to visualize this, think of marriages. Alright, I probably wouldn't be cool if my wife went out and married another dude, right? And I don't think she'd be happy if I went and married out some other chick, okay? It's a one-to-one relationship. Like, we have exclusivity in that we're not allowed to go marry other people. And if you're not a visual learner and that is just the dumbest thing you've ever heard, then forget it. One-to-one. This is the relationship of an entity and an attribute. So when you have an entity, such as a class, the attributes would be the time of the class and the location of the class, and the class name, the class ID. Stuff that is unique to that class. Just wanted to mention that there is a little bit of flexibleness allowed in this. For example, when we say one-to-one, we're basically saying this class has one name, and this one name is assigned to this one class. Now, like I said, that's not always generally true, because we could potentially have another class with that same name. But if you think about the purpose of a class name, it's an attribute to describe an entity. I'm really not trying to make this too complex, right? So I'm trying to give you the most technical, correct definition of this, right? A one-to-one relationship is essentially a column within a table, and that column is unique to that entity, even though the value of that column could be repeated in another row. Did I lose you? I think I just lost myself. Let me give you a picture, right? We have this dude and we have this dude. There's a couple different ways we could store this in a database. First, we can put them both in one table, and we could make them both have their own row, which would be the way we would want to do this. And now this person has a name. So we have a Caleb, and we also have a Caleb. This would be the proper way to design this. One-to-one relationships. You put the attribute as a column within the entity table, which will be people. Sorry, my neighbor's parking his car, making a bunch of noise. What a noob. Attributes are a value within the name column, and they are unique to each entity, but there's a repeating one. So an alternative way to design this, which you should not do, is to make another table known as names and have Caleb in here once with an ID. So let's say this has the ID of 1. And then we could reference that. That's a total possibility, and in fact it would work. But it's unnecessary strictness. Just because there's a possibility that the attribute could be repeated doesn't necessarily always mean that it's a one-to-many relationship. If I haven't lost you yet, good. If I have, let's just slow down a little bit. The only thing you really need to remember or think about is that a one-to-one relationship is an entity and an attribute. That's all you gotta know. Just ignore all this stuff, you know. The second example of relationships that you need to know about are one-to-many relationships. Now when we're talking about one-to-many relationships, we're starting to talk about relationships between two entities rather than one entity and one attribute. In this example we had an entity and an attribute, but in this one we're actually going to have a relationship over two tables. And if you remember, I was talking about entities. I said each entity gets their own table. So the example I got for this one is you got like a gym, right? Generally gyms will have some kind of membership, right? Some gyms have a tiered membership system. You can find the same thing on websites. You can pay $10 a month for the good version, and then you can pay $10.99 per night for legit version. Right, so those are like a tiered membership. So let's say in this theoretical gym we got 3 tiers. We got bronze, silver, and gold. So over here we have the membership table, and we have 3 entries or rows. So these are basically going to be 3 rows in our membership table. And over here we have customers. And don't worry too much about my spelling or anything. We'll get into all that later. I'm just using for theoretical design. I'm just writing what I'm talking about. I ain't following no standards. Well, in this table, each customer is going to get a row. So we have 3 customers. Each one's going to have a membership status. The way this works is with an ID system. Each one of these is going to have an ID. And with these numbers, you can basically correlate it. So this guy, he is the gold membership. This guy has the silver, and this girl has bronze, or let's say she has gold too, right? That's how that works. And just so you know, you don't have to use IDs, but you need some kind of primary to foreign key relationship, which we'll talk about that in a couple minutes, if I got time. This is an example of a one-to-many relationship because one membership status, gold for example, goes to many other entities. So we have 1 to this guy and to this girl. To follow this, you got 1 to many. Many being more than 1. It doesn't have to be like hundreds, it can be 2, for example. So that's the way this kind of works in a one-to-many relationship. There's a connection between the customer's entity and the membership entity. So in a one-to-one, you have an entity and an attribute, but in a one-to-many, you have two entities. And once again, for your visual learners, this would kind of be like if my wife was like, yo bro, I know we're like married and such, but I'm gonna have multiple wives. I'm gonna have multiple husbands, but you're not allowed to have multiple wives. That's not cool, and if you do, we're done. That's kind of what a one-to-many relationship is, because you'd have one husband has one wife, but the wife can have multiple husbands. Sorry for all the details, but getting on to the final, and probably your future least favorite of them all, many-to-many relationships. I can talk. The way many-to-many works is that one entity could have a relationship with multiple other entities, and each one of those entities could have relationships with any number of other entities. So kind of be like, yo, wifey poo, I know we're like married and all, but I think we're gonna be allowed to have as many wives and husbands as we want. Or that would be full polygamous marriage. But to put that into a data perspective, let's use a different example. We have people, and then we have classes. So students and classes, essentially. One student can take 20,000 classes, and one class could have tons of students. So if you think of you have one student, and that student has a relationship with multiple classes, it'd be like, poof, poof, right? Like pointing to 4 classes, for example, you get like this effect. You know? And then on this side, you have one class which has 30 students. So you get like times like a lot, right? And then you just get these lines going all over the place, right? And at the end, you just got this big mess, right? So this is one of the harder ones to store in a database, and it requires what's known as an intermediary table. You may also hear this as a junction table or a many-to-many table, or who cares? There's all kinds of different names for it. But basically, the way this is going to work is you're going to have 3 tables. And this here, this intermediary table, is right here, smack dab in the center of them, separating them. You know, you don't want all those lines crossing over each other, so that'll just be bad. And then you're going to put all of the relationships in this table. So within this intermediary table, let's say this table here is students and then classes. So we got students, classes. Within this table, you're going to associate a student with the class that that person's taking. So you would have Caleb, math, Caleb, science, Caleb, geology. And then once you go through all the classes that Caleb has, you go on to someone else. Jimmy, math. But Jimmy doesn't have a science class. So you just go straight up to geology. And these names are going to be replaced with IDs, or foreign keys to the students table. Did I lose you? But basically, you're going to have, let's say Caleb has the ID of 27. Instead of having Caleb, you're going to have 27, 27, 27. And that's going to link the tables. So that way you don't have them break apart. So there's still that connection, links, but they both come to the intermediary table and stop there. For you visual learners, think of like 2 tables shooting out laser beams, boom, and then it hits this magical force field of this intermediary table, and it absorbs all the electrical energy juice, and then puts it in a beautiful display of students to classes. And right now you don't need to understand all the details of how to make an intermediary table perfectly. If you want to know more about that, I have a 50-some part database design series that you can go watch for days, okay? I'm just trying to get the basics, and this video has been way super too long, so let's just end with that. for the relationships, but I still have one more thing I need to talk about, which first we'll summarize this and then we'll talk about primary keys and foreign keys. So many-to-many is also entity and entity connecting multiple entities, but with an intermediary table. So entity and entity with intermediary table. That is how we would memorize that. And if you like to think about tables, like how many tables do these things take up? This is 1, this is 2, and this is 3. Okay, now let's talk about primary keys and foreign keys, and then we'll talk about one more thing regarding relationships, regarding those keys, and then we'll be done. So there are 2 types of keys in database design. There's primary keys and foreign keys. So these are the kinds. Now there's also categories. So those 2 categories are natural and surrogate. These are basically the way the keys work. So natural would be something that has real world meaning. So something like an email address would be a natural key because it has real world meaning, like I just said. A surrogate would just be like an ID of 743, which is just a random number, computer generated, doesn't mean anything in real life. And the fact that it's just a random number. That's it. But I guess I skipped a step. What are keys? They're basically things to keep things unique. The keys are used to basically make every single row within a table unique, and also they're used to make connections across multiple tables. The difference between natural and surrogate is minor, and it's kind of a conflict between database designers as, oh wow, you should use natural, or oh, you should use surrogate, or oh, you should mix them. It's not a super huge deal in reality. I tend to prefer surrogate, but I'm not completely against natural, so just for those of you who are wondering, natural or surrogate. But that doesn't matter. So let's just talk about primary keys and foreign keys. The primary key is the key column within a table that makes that table, which makes every row in that table unique, right? So if you have a users table for a website, every single user is going to have, in this case, a surrogate key of a random generated number. That makes every single row unique. So that way, if you have a person with the same name as someone else, you can tell that they're different things, right? So if you didn't have these keys and you just had Caleb and Caleb, well then you have to ask yourself, okay, is this a duplicate or are these 2 separate people? And you don't really know. But if you have a key, one of them is named Caleb with the ID of 72 and one of them is Caleb with the ID of 483, well now you know they're 2 separate entities. One's Caleb with this ID and another one's Caleb with this ID. So let's just draw faces to represent people, and we're going to give each one of these people an ID. This face here, you wouldn't store that inside of a database. I mean, you could store a picture, but that's not what I'm trying to do. I'm just trying to give a visual representation of what each one of these rows refers to. It refers to this person. You know, it's like, how do you talk about the person? Well, it's this person. Got these 3 people. We'll give them some hair so they have some confidence. This one's a squid. Alright, so these 3 people each have a row in the database, in the table of the database. The table is whatever is what you're storing, so in this case, users. Now a foreign key is a reference to a primary key in another table. So if this is that gym we're talking about, we would have a column foreign key, which would say membership status, for example, and you would have, let's say, 2, 2, and 3. These are foreign keys, and they reference primary keys of another table, which in this case would be membership status. Each one of these is going to have a primary key. Every single table is going to have a primary key. If we're using IDs, well, we could just say 1, 2, and 3, just computer-generated numbers. Now there's a link between the foreign keys and the primary keys. See this number here? Well, this is a foreign key, and it has to match a row with the same primary key. So this foreign key references the silver. This one also references silver. This one represents gold. And you have these links, and you can enforce those links with something known as foreign key constraints, which we'll talk about in a future video. That is basically how this works. Primary keys, foreign keys. Foreign keys reference the primary keys. Every single table needs a column that has a primary key to make every single row unique. Then you can enforce that with foreign key constraints. So when it comes to those database relationships we were talking about, the way we design our primary keys and foreign keys are very important. So we're going to go through them real quick and describe how this works. The first one being one-to-one is the easiest. You guys will love it. All right, you don't even need to worry about multiple tables. You have a table, and then one of the columns is going to be the primary key, and then you put the relationship in another column. It's simple, entity and attribute. The entity might be users, everyone has their own ID, and then an attribute would be like the user's name. Caleb, for example. That's all you gotta do. You make a column. Boom, done. Simple. I know, it's awesome. I wish it was all like that. For one-to-many, it's a little different. Let's use the example of the membership again. You're gonna have two tables, and this one it's going to be the users. So you're gonna have a primary key of the user ID, and then you're going to have a foreign key which references the primary key of the membership. The foreign key goes in the child relationship, which we never even discussed really that much, children and parents, but you can think of it like this. You can have one entity, such as gold, which can be used or whatever by other entities. For example, Caleb and Sarah and Samuel. Right? This will be the parent, these will be the children. Well, these people are all stored inside of a table, each with their own row, and then the foreign key, each one of these has a foreign key. So this is going to have a foreign key of 3, foreign key of 3, foreign key of 3, because they're all gold members. It makes sense. So for one-to-many, the one side has a primary key, the many side, which would be the children, has a primary key and a foreign key referencing the one side. Great. All right, let's go over many-to-many. In this situation, we get 3 tables. And let's say it's books and authors. One book can be authored by many people, and one author can author many books. So you got this many-to-many relationship. Well, we can put books over here, authors over here. The foreign keys are going to go in here. So you're going to have a foreign key to the book and a foreign key to the author. Now there's one small thing of debate that some people have as to whether you need a primary key to describe the whole group. So if you did, you'd need 3 columns. If you don't need the primary key, then you just use both of these as the primary key. I'm just going to say up front it doesn't really matter, but in this situation we'll just keep it as this. You can interpret it however you like. But basically, the foreign key is going to reference the book, and the foreign key is going to reference the author. So you could have one author, this person over here, with the ID of 47, who authored 3 books, 38, 27, and 19. Those are the IDs of 3 books. The way it'd look in here, you would have 4738, 4727, 4719. That is how a many-to-many relationship works. Well, congratulations. If you've made it this far, you officially got through the database relationships section. One of the most fun and interesting sections, but it can also be very time-consuming because it's very conceptual and, kind of annoying, and you kind of just want to, take the whiteboard and smash it on something to help you think or something. I don't know. But hopefully that was helpful. Sorry, this is probably one of the longest videos I've ever posted. But anyways, thank you for watching. I'll see you in the next video, and hopefully you guys are learning and enjoying this. Thanks, and I'll see you then. Peace out, guys. Peace.